this is what I'm actually feeling a bit like comfortable and excited about. We're gonna prove the famous socks and shoes property of matrix multiplication for inverses. That's what true. That is like if I get A times B and then I invert the entire mess, that's the same thing as B inverse times A inverse. And a helpful statement to play around with to show that this statement is true is we're gonna use either AB times the fact that AB times the inverse of that element of that matrix gives you the identity matrix. Now, in the textbook, we'll put like an identity matrix of size 2, but could be any finite dimensional identity matrix. And this could be in any order as well. You could do AB inverse times AB equals I to the n. So I'm going to prove this fact first, and then I'm going to explain the analogy where it holds. Okay, so starting with here, again, we can't assume this thing here in inverse, otherwise you're begging the question. AB inverse equals I to the n. Actually, no, I felt more comfortable seeing this one here. Okay, I to the n. So the only thing you can do is you can only unpeel the layers of the adjacent matrices next to the bigger matrices one by one. like peeling layers of an onion. So one thing I can do is I have AB inverse here, AB equals I to the n. I'm going to go and multiply by B inverse to both sides. B inverse, yeah, B inverse will be multiplied on the negative side. Oh, god dang it. So we get B inverse pair here, which is basically yet another identity matrix, but any matrix times identity matrix is just whatever that matrix is. B inverse here. So I get AB negative 1, A... Oh, okay, it does work. Okay. I guess I was just nervous in that regard. IN equals B inverse. Which then becomes AB negative 1, AB inverse here. And then I multiply by A inverse to the right-hand side. And to make the steps very explicitly clear, I'm going to go and bold these, or rather color them in red. And I mentioned to explain reasons here. Multiply B inverse on right of both sides of equation. And this is multiply A inverse on right of both sides of equation. This A and this A inverse just cancel out in the end again. AB negative 1, I, N. B inverse, A inverse. So yes, we successfully proven it. That AB inverse equals B inverse, and then A inverse. And now the fun part, which is drawing the analogy with it with socks and shoes, this name, socks and shoes property, which is like the act of putting on your socks and your shoes. Think of it this way first, in terms of like a process, in terms of acting. When you go and start your day, you need to put on your socks first. Then you put on your shoes. However, once you're done with your day and you come back home, if you were to go and like fully undress yourself, you would need to take your shoes off first. Offered. Then finally take off your socks. So it's a complete opposite thing, and that's basically a real life situation analogy that corresponds with this nice little rule of matrix multiplication. So yeah, okay, this one was clear. I really enjoyed this video. I hope you did as well. Please let me know in the comments anything I can do to improve otherwise. Thank you.